All right, today's lesson is method number 3 for graphing a line, which you have learned already. It is basically the same as method number 1, except now you're looking for specific points.
Is the exam going to be like
Sort of equal parts of everything that we've done.
Will we get like a review?
Oh, definitely.
Well, we don't get it before winter break.
Well, if you'd like it on winter break, I can get it together so that you. I mean, obviously, parts of the review you couldn't do because it's on the last unit that we haven't got yet, but can definitely give you an idea of what's going to be on your exam. So for your review, the reviews are actually a lot of your reviews are actual old grade 10 exams. So you get to see an exam, see what it looks like, and do it. Now the difference between your exam and those exams is the students that wrote those exams wrote it all at once from beginning to end. And yours will be broken into 2 parts. So you'll do one part one day, another part the next day. But the entire year will be on both parts. But one day will be the calculator part. So calculator part, you'd have to say, well, what units did we use our calculator more? Definitely in trigonometry, you needed your calculator for. Some things in measurements, we needed our calculator for. We didn't use a lot of calculator, like our whole last test was non-calculator. So relations and functions, that's going to be on non-calculator stuff. A lot of stuff we did here is non-calculator. So it's going to be a mix that way. Yes, question? Yeah. So basically, this method, the x and the y intercepts, is very similar to table of values method, except you're only looking at these 2 points. You're looking at one point where the x coordinate is 0, and one point where the y coordinate is 0. And so all we do is we plug in the x coordinate of 0 and solve for y. We find our y intercept. We plug in the y coordinate as 0, solve for x. You find the x coordinate. And technically, if you have 2 points in a straight line, that is enough to graph the straight line. So in the table of values method, we like to find 3 just to make sure that we didn't make a mistake with one of them. The intercepts, you're like saying, okay, I'm confident I didn't make a mistake. I'm just using 2 points. But it wouldn't be bad, right, to do an extra point anyways, just to verify and make sure. So here's our first one. If we're using the intercepts method, you could find your x-intercept. In brackets, I'm going to say, I'm going to make y equal to 0. 0 would be equal to x plus 5. Could you get the x by itself? Yes, you could subtract 5 on both sides, and then you would get x equal to -5. That's our x-intercept. -5, 0. To find your y-intercept, same process, but now you're plugging in 0 for x. You would get y equals 0 plus 5. So y is just equal to 5. 1, 2, 3, 4, 5. Label that point, and technically that's enough to make sure that you've got it right. If you wanted to, you could double check things. Like you could plug in 1. And if you plug in 1 for x, do you see that you would get 6? To get that third point, do they all 3 line up on the straight line? Then you know for sure, I think I've done it right. If you find that third point and something's off, it's telling you, I should probably check over my answers. I might have made a little mistake somewhere along the line. Ooh, would you like that? I made a mistake somewhere along the line.
I think you made a mistake somewhere along.
You think I did?
I don't know what you made a mistake. I made a mistake.
There we go. And we draw our line, put arrowheads on the end. And we've got our first graph. Everybody done? Even Brielle? Oh, she's always not done.
She said she's gonna watch the video.
She's gonna watch the video. I sometimes like to find the y-intercept first because plugging in x equals 0 is usually like the easiest. And you see in this one, you can find the y-intercept by plugging in 0 for x. But do you see that it's already in y equals mx plus b form? That if it's in y equals mx plus b, you know that the b value is your y-intercept. So you could have just looked at the equation and said, I know it's going to be 2. So I go and I label 0, 2 on my graph. Then when I find my x-intercept, where I plug in 0 for y, now I've got a little bit of math to do. I want to get the x by itself. So I'm going to subtract 2 on both sides. And then the opposite of multiplying, I'm going to divide both sides by -2. And I get x equals to 1. So I go to my graph, and I can label 1, 0. Now technically that's enough to draw our line. This time for my check, because we've already learned the y equals mx plus b method, can you see that in our case our slope is -2? Can you see that I go down 2 over 1? So I can use that as a way to check. Draw your graph, put your arrowheads on the end. But it's good if you are using one method to like think of another method to check. So this time I used y equals mx plus b. I checked the slope, it matched up. It made me feel like everything was right. Okay, one for you to try. Actually, I think the next 3 are full. The last 2 are a little bit different. But I'll let you try example 3 on your own. Okay, check how you did. I didn't show any work. So when you plugged in 0 for x, did you get -3 for y? When you plugged in 0 for y, did you get 4 for x? Draw those points, draw a line through them. And then the last 2 examples, it's sort of like, how does this work with the special lines? And so do we remember? We had special lines that some of them are horizontal, some of them are vertical. Y equals 3. Will that be a vertical line or a horizontal line?
Horizontal.
So if you have y equals 3, your y-intercept when x, hey, what is y equal to when x is 0? Well, y is always 3. That's what y equals 3 as a line means. It's telling you y is always 3. So when x is 0, y is 3. When x is 1, y is 3. When x is 2, y is 3. When x is 3, y is 3. When x is -7, y is 3. This is the horizontal line. Can you see that there are no x-intercepts? Because if you plug in 0 for y, can someone tell me what's wrong with this? If you plug in 0 for y, and you try to solve, 0 is equal to 3. If you think this is good math, give me $3, I'll give you 0 back. And we'll be all equal. You can make, if this was good math, you could make a lot of money. People give you $3, you're $0 back, everything's good. And then, same thing with the x equals line. When y is 0, x is -2. When y is 5, x is -2. And no matter what y value you put in, you would have an x-intercept at -2, 0, but you would have no y-intercept. Because if you plug in 0 for x, you would get 0 equals to -2. Again, that doesn't make sense. So we've got our special lines that go up and down as well. Nice short lesson for today. You like that?